This section that we're going to do in this video is looking at a special math skill we often need in the sciences, and that's scientific notation. So scientific notation has no magic involved. It just is a nice way of writing numbers that are really big and really small so that we don't have to write out so many decimal places or so many zeros at the beginning or the end of our number. So what we do to shift our decimal place over so we don't have to show all those zeros is we use a power of 10. And remember, something times 10 moves it over a decimal place. Something times 100 moves it over 2 decimal places. So if we take a power of 10, all we're really doing is moving over the decimal place. So let's look at these examples here. First we have 15,000. So if we want to write that in scientific notation, we're going to need to move the decimal place over. Always in scientific notation, there is one non-zero digit in front of the decimal. So in this case, that's going to be the 1, and the other stuff is going to go behind the decimal, so the 5. So we need to move that decimal place over, right, all the way over there, so that's 4 decimal places. So when we move it over 4 decimal places, we also have to have 4 decimal places of our power of 10. So what we have here, 1.5 times 10 to the 4, is saying that's shifted by 4 decimal places. Because this was a large number, we have a positive power of 10. When we have a small number, like the next example, we're going to need to use a negative power of 10. So again, we're going to have to shift it over so we have one non-zero number in front of the decimal place. So we're going to need to get to behind the 2. So to get to behind the 2, we again moved over 4 decimal places, so this time we're going to have 10 to the minus 4 for our answer. The next 2 examples both have negative values, and that's okay, right? Sometimes in science things have direction, or like in Celsius we can have negative values. We still do the exact same method. We move over our decimal place and we put the appropriate power of 10. So this one, we're only going to move it over 1 decimal place, so our power of 10 ends up being 10 to the 1. Notice on all of these we do not forget to put our units, and we don't put our units in the middle of our number, right? It's not 1.5 grams times 10 to the 4, it's 1.5 times 10 to the 4, and then we have the grams. Always the units at the very end. So this one, I moved over this way, my number got bigger, my number got smaller, my power of 10 got big. They always move opposite directions, right? This front number got small, my power of 10 got big. This front number got bigger, my power of 10 was small, 10 to the minus 4. So same thing on this one, my number is going to be small, going to move over 2 decimal places, so I get negative 1.23 times 10 to the minus 2 newtons. The next 2 are a little tricky because they already have a power of 10. They're not in scientific notation though. Remember, scientific notation, we have 1 non-zero digit in front of the decimal. And here we have some 0 digits in front of the decimal, and here we have 4 non-zero digits in front of the decimal. So to get them into scientific notation, we have to move the front part to move the decimal, and then we change the power of 10 accordingly to get the right power of 10. So as one goes up, the other goes down, and vice versa. So in this case, when I go from 0.01 to 1.75, that number is getting a lot bigger. So my power of 10 has to get a lot smaller. So if we look at that, my number here got 2 powers of 10 bigger, right, because I moved over 2 decimal place. So my power of 10 has to get 2 smaller. Keep in mind when it's negative, negative 5 is smaller than negative 3. So we went 2 down from negative 3. So same thing's going to happen on this next one. We've got to move our decimal place over 3 times. So we're getting 3 powers of 10 smaller on the numerical portion, bigger on the power of 10 portion. So that's going off my screen, sorry about that. So that's going to give us 4.2 256 times 10. So if this is getting 3 bigger, that's going to be 10 to the 7. And I see I missed my other arrow, so let's get that in there. So my power, let's finish that off to the 7. And again, don't forget the units at the very end. See if I can make that squeeze into there. So it also works going the other direction. We're going to move our power of 10 over so that it's not there anymore. And so we move our decimal place accordingly to make that happen. So here I've got 10 to the 6. I need to move this over 6 places. So this is a large number. So when that goes away, we're taking it down. This is going to have to be made smaller, right? Sorry, bigger, because my power of 10 is being made smaller because it's disappearing. So I move this over 6 decimal places, so 1, 2, 3, and then to do 3 more decimal places, I'm going to need 3 zeros. Probably would help if I had an equal sign there. This one I'm moving the other direction. So 10 to the minus 3, I need to get 3 smaller. So 1 takes me to the front. I'm going to need 2, 3. So I need 2 zeros in front of there. And if we're writing this really properly, we put 0.00. So when you're working on questions like this, you do have to remember to leave yourself a little space, because sometimes people want to move over there and they haven't left themselves room to put in those front zeros. So same thing here, 10 to the minus 1, I move over 1 decimal place, it gets 1 smaller in the front, I get 0.065 seconds. Now 10 to the 12, I'm going to have to count over quite a few decimal places. And this thing's not going to happily let me keep it on the same line. Not sure why it's doing that, because I did not hit equals, not enter. So if we put all that in here, 12 decimal places, right? So 1, 2, 3, we're going to have to keep doing this, right? 8, 3, that's 1 decimal place. 4, 5, 6, 7, 8, 9, 10, 11, 12 decimal places. Now a lot of people find that a little bit difficult to read, so they'll often put a space in there just to make it a little easier to read, so that we have the right things there. And again, don't forget your units at the end. So when you're putting scientific notation into your calculator, a common mistake is not to know how to use your calculator properly. So scientific notation on most calculators, when you're entering it, there's a special button on your calculator that does the times 10 for you. That special button on your calculator depends on the model of your calculator, but the 3 typical things that it looks like is either an EE, both capital, EXP, also usually in capital, or 10 to some symbol representing an exponent. So it might be 10 to a number, or 10 to the n, or 10 to the x. So those are the numbers you tend to have, those buttons you tend to have on calculators that will put in the scientific notation for you. So when you're putting those in, when you type this in, and I'm actually just going to show it with the first one, and I'm going to use the EE notation, but your calculator might have a different button. So if you were putting it on those calculators that have an EE button, you would go 4.539, and then you don't go times 10, you just press that EE button, and you press the 6. So that's what the calculator might even display it like that. That actually means 4.59 times 10 to the 6. and then you would, as usual, hit your subtraction button. 2.17 EE5. If you are typing in times 10 to the power, all as separate buttons, if you do it properly, it'll still work, but it takes a lot more keystrokes. But people tend to make mistakes because the calculator doesn't treat that all as one big number. And it starts doing funny order of operation things when you start especially multiplying and dividing. So if you are consistently getting the wrong power of 10 when you punch something like this into your calculator, you probably are not knowing the right way to use your calculator, and you need to check in your instruction manual or talk to your instructor. If it's me, certainly we can make time to do that. So that's how you type that into your calculator. And if you type it into your calculator correctly, it may or may not show it in scientific notation. You might have to convert your final answer to scientific notation. So these 4 questions are in here so you can practice using your calculator. I'm going to post what the answers are so you can test your calculator. Go look up the instruction manual if you're consistently not getting the right answer, or speak to someone who knows how to use that sort of calculator, because it'll make a world of difference if you know how to use your calculator properly. So the answers here, just going to put them on this display. So you can do each of them and check that you're getting the right answer. And this last one, some calculators will display it wrong just because it won't put it into scientific notation, but it won't show enough decimal places. And that's because, why did that show up so funny? Give me a sec. There we go, that showed up better. Because some of them will only display so many decimal places, and if it doesn't automatically flip to scientific notation, you probably aren't seeing the last digit or maybe the last 2 digits. So you may have to switch your calculator to scientific notation. Again, how you do that differs on different calculators, so be careful. So I will leave that. Actually, let me put an enter there so it looks properly. So there's the answers. Check them out. Make sure things are working right. I am going to put a note there about those calculators that maybe you need to switch it to scientific notation to get them to display right. And that's scientific notation in a nutshell.